In this video, we are going to solve a few questions on finding the probability using the addition rule or the multiplication rule. This question here is given an urn contains 7 red marbles, 10 white marbles, and 10 blue marbles. A child randomly selects 3 without replacement, so we do not put it back. After we take it out, then we do not put it back to the system. Round to 4 decimal places. Now part A is asking to find the probability all the 3 marbles are of the same color. So you want the probability of getting all 3 marbles with the same color. So how do I find this probability with the same color? So you want the same color, that means you want the probability of all 3 red, right? Or all 3 white, or all 3 blue. So those are the 3 cases that you can get 3 of them to be the same color, and we use the key word here is the or, because you may get like all 3 red, or all 3 white marbles, or all 3 blue color. As long as one of these conditions that you can get, then you meet the requirement here. Now remember that this is the OR case, so we can use the addition rule. So we can go ahead and we can split this one into the addition. Probability of all 3 red, or is the addition probability of all 3 white, and then add to the probability of all 3 blues. Okay, so inside the all 3 red, you know that you are taking out 3 marbles, right? So this is 3. So 3 times, that means they are all the multiplication rule. You can use the multiplication rules for the 3 marbles. So all 3 red, we know that we have 7. We have 7 red, we have 10 white, and we have 10 blue. So together we have 27. So out of 27, you want the first marble to be red. Red, we have 7 out of 27. 7 choices out of 27. Now, because we do not put the marble back to the urn, therefore you have only 26 left inside. And then now you want the second one to be the red, and because we already took 1, so we have 6 now. 6 red out of 26, the chance. And then lastly, we do not put it back, so we have 25. And because we took 1, so now we have only 5 red out of 25. So this is the probabilities of getting all the 3 marbles to be the red. Or that is plus, and then the same thing, all 3 white. The first marble, you have 10 white, so 10 out of 27. And then you do not put it back, so you have 26 now. And then you took 1, you have 9. And then you took 1, you have 8. This is 25. And the same thing here, all 3 blue. We have 27. Blue, we have 10. And then because we do not put it back, we have 26 left. And we took 1 from 10 blues, now we have 9 blue. And then the last marble, we have 25, 8. Okay, and if you add all of them together, you should get, or if you convert it back to the decimal places, 0.0940. You move it to 2 places to the right, that is about 9.4%. Small. Okay, part B. Find the probability that none of them are white. Okay, so you have again you have 3 marbles. 27 is the total. Now you don't want the white, right? So white is here. So cross it out. So you have a total of 10 blue and 17 red. So the first marble you can have 17 out of 27. Now because we took it out, we have 26 left, and then we have 16, and then because we took 1 out, 25, and then we have 15. So 17, 16, 15, they are the numbers from the red and the blue, and they are not from the white. So multiply these 3 fractions, you should get this number here. In this problem, let's read over the problem. Inside the box of every cereal box contains a surprise gift. The store manager assures the employees that 12 of the 49 boxes on the shelf have a secret decoder ring, and inside the other 37 boxes on the shelf contain a different gift. If 2 cereal boxes are randomly selected from the shelf to purchase, what is the probability that both of them have the secret decoder ring? Okay, so we are looking for the probability that both of them have the secret decoder ring. So that means you want the first box with the ring, decoder ring, and also you want the second box that the people buy it. The second box also has the decoder ring. So you want this condition, right? Because you want all of them to contain the secret decoder ring. Now the key word here is the and. The and tells us that we can use the multiplication rule between the first probability, the first box with the ring, and we just multiply with the second box, the probability of that with the rings. So together we have a total of 49 boxes. Alright, so you have 49 boxes, and you want the one with the decoder ring, secret decoder ring, and we only have 12 of them. We'll have that. The other 37 boxes will have the different gift. So 12 of them will be the secret decoder ring. So we have 12 out of 49. Because we are looking for the ring, the chance of getting the ring, the decoder ring. Now, because we get the box away from the store, therefore, the second box, we only have 48 left. And then if we want another chance of getting the box with a ring, then we have 11 boxes left. 11 boxes left for the secret decoder ring. So 11 out of 48. And if you multiply all of this number together, you should get 11 out of 196. And that will be 0.0566. So 0.0561, 0.056, around that. So that's the answer. And if you move 2 places to the right, so this is about like 5.6%. So a very small chance of getting 2 boxes, and all of them contains the secret decoder ring. In the next problem, this is a problem about the lottery games. So in the lottery games, a player picks 8 numbers between from 1 to 53. If 7 of them match to the A numbers, then the player wins second prize. So what is the probability of winning this prize? So anytime you are asking for the probability, we know that we need to find the ratio, and the bottom is the total number of possible outcomes. We have 53 numbers, right? 53 number, and you can choose any 8 numbers out of 53. So the total number of the possible outcome is, we use a combination 53, choose 8. And the reason that I'm not using permutation, because the A number could be anything and the order does not matter in this case. So as long as I pick out 8 number from 53 numbers from 1 to 53. Now the requirement is, if 7 of them, 7 out of 8, if you can get 7 out of the 8 numbers that were chosen, then you win the prize. So it's telling you that as long as you have 7, you have 8 chosen number, and you can choose 7 that are matching to the number 8, then you are okay. And again, the 7 number can be in any order. The order doesn't matter, so you see in this case. And then the order 1 number, because this is 7 number only, but we have 1 number, so the order 1 number is must go to the order 53 minus 8. Remember, so 53 after we pick out 8 number, right? So we have 45 left. So 45 number is the 45 non-winning winning number. So 45 non-winning numbers. And now you just want to take the order remaining number from the 45. And then you want the 2 requirement to be together. That's why we use the AND case, and that is the multiplication between these 2. So you want to take 8 combination with 7, that's gonna give you 8, and then 45 combination with 1, so 45 times, that is 45, so 45 times 8, that is 360, and then 53 combination with 8, that's gonna give me a huge value, like 8863222710. That's a very large value, and that is your answer. Okay, let's try the last question here. A poker hand consisting of 6 cards is dealt from a standard deck of 52 cards. Find the probability that the hand contains exactly 4 face cards. So just a quick reminder, from the 52 card, the standard deck of cards, we have 12 face card, and then the other 40 non-face card. Alright, so again we are looking for the probability, so you want to take the ratio. In this case, you know that the poker hand consisting of 6 cards from 52, so the total possibles of the outcome you can get is, you have 52s and you are choosing 6 out of 52. So this is the total number of the outcomes that you can have. But you want exactly 4 face card only. So we know that we have 12 face card. 12 face card. Now you want to choose out exactly 4 of them only. Now because we have 6 of them, right? 1, 2, 3, 4, 5, 6. The first 4 you want them to be from the face card. So 4 chosen from the 12 face card. and then the other two car, because we have 6 total, this is 4 only, so the other 2 car, you want that 2 car to come from the other 40 non-fake car. So you want the 2 requirements to be together, and therefore you need to use the AND requirements, and the AND means the multiplication. And that is the answer for this particular problem.